Welcome. Uh, this lesson deals with problem solving in physics, and in my experience, I have seen a lot of people who, despite knowing the concepts, are not able to get correct answers all the time because they are not aware of the process of problem solving. So, the problem solving has these steps. Number one, make sure that you understand the problem. I have seen some students have the tendency of jumping in without spending a few minutes trying to understand the problem. Even though it may seem that, oh, I don't need to spend any time, I can just start solving it. But it does help you if you give yourself a little time to understand the problem. Next is identify which principles can be applied to the problem. Is it conservation of momentum? It is a component of forces, etc. Third is perform dimensional analysis at each step, and we'll go into this in a little more detail. Number 4 is use symbols till the end, plug in values at the last step, and evaluate your final answer for plausibility. So for example, if you are calculating say a mass of an object, if it's negative, then you know that it is wrong. So that's one example of plausible and implausible answers. Now most exams have become objective, like IIT JEE or NEET, and questions are like these. So you must be wondering that why bother about learning all this when all you have to do is pick up one option that is given, one of the 4, and if you choose randomly anyone, chances of your being likely correct is 1 in 4. But that should not be a goal. You cannot pass or get admission into a good college if your hit rate is 25%. So question is, why care to learn all this? So please read this statement carefully. If you become very familiar with the process, you'll be able to perform many steps in your mind. But if you're not familiar with the process, you are likely to make a mistake whether you solve the problem mentally or on paper. So as you become more and more familiar, you'll be able to do some of it in your head. But if you are not familiar with these 5 steps, then your chances of getting a correct answer will be 25%, 1 in 4. So let me review a very important topic called dimensional analysis. So let me pick up my blackboard. So the topic here is dimensional analysis. This shows up in chapter for units and measurement, but you don't learn it there and forget it, because in classical physics, classical mechanics, you will use these principles in every problem. This is very important to become familiar with dimensional analysis. So what is dimensional analysis? So there are 3 fundamental units. mass, and it's written as m. Length written as L, and time written as T. Now based on these we can derive more entities like velocity, speed, etc. So let's look at velocity. So vector. So velocity is displacement over time. So this will lead to L t minus 1. Speed is distance over time, and this leads to L divided by T. So again is L t minus 1 raised to the power minus 1. So you see that velocity and speed have same dimensional form, and in dimensional form you don't show vectors. Now acceleration is a vector. So acceleration is rate of change in velocity divided by change in time. So this will be the dimensional form of velocity, which is Lt minus 1 divided by t, which leads to L t raised to the power minus 2. This is your acceleration. Now force is mass multiplied with acceleration. So this will lead to m L t raised to the power minus 2, as we saw in this step. Work is a dot product of force and displacement. So the dimensional analysis of work would be, we saw in the previous step, mlt raised to the power minus 2 multiplied with L. So this will lead to m L square t raised to the power minus 2. Kinetic energy. Let me use a different color to keep the rhythm. Kinetic energy, half mv square. This will lead to, we don't have dimensional notations for or need for constants, so we ignore this. M and velocity is Lt raised to the power minus 1. So Lt minus 1. So this leads to m square, sorry, no square, L square t minus 2 square. So you see this looks a lot like identical to work. So this gives you an idea that work and kinetic energy could be interchangeable. That's not always true. And lastly, let's take momentum. momentum is mass multiplied with velocity. Momentum is a vector, so this becomes mass L implies -1. So this gives you a basic idea of how to apply dimension analysis to different objects like velocity, speed, acceleration, force, work. And I recommend that you study this yourself in detail, because you'll be using it again and again. So now let me bring up a problem that this was in JEE mains some time ago. So we will apply the principles of this into the process that we have learned. So let me go back to my blackboard and clear this out. Let me make this little bigger. All right, so let me copy this problem from here, just the problem, and I paste it here. Okay, so the first step is that you spend time in understanding the problem. So I have drawn this picture beforehand, and you see what I did here, and you compare this with the picture that is here. Let me copy this also. Here. So what I have tried to do in this to help me understand the problem, I did the picture, and let's see if I captured everything. So the block of mass M, 10 kgs here. So this is the use a different color here. So the first thing it tells you that there's a block of mass, and that we have taken care of here. M is kept on a rough inclined plane shown in the figure. So this is my rough inclined plane, and I have it. A force of 3 Newton is applied on the block, and here is given you the direction. So I have this force F in blue, so I took care of that too. The coefficient of static friction between the plane and the block is 0.6. So I have this force here, and maybe I can also write here mu for the static friction. And then what should be the minimum value of force P such that the block doesn't move downward? So I have this P here. Next step, let me write down all the variables. All right, and let me remove this picture because we don't need it anymore. All right. So all important variables here I have written: mass, force, P is an unknown. This is what we need to know, very important. Phi is 45 degrees, mu is 0.6, and force of gravity is mass multiplied with g, and let me write g is 10 meters per second square minus. So usually this is 9.8 is usually 9.8 meters per second, but I think to help the students do this problem quickly, they have given value 10 meters per second square. And you may be thinking that why I'm going so slow, because my goal is not to solve the problem. My goal is to show you the process of solving. So the first step we did, we created this diagram in detail and we listed all the variables that have a role to play in this. Some were in the question themselves, and some, like this force of gravity, we had to apply here. So let's go back and look at the steps. Make sure that you understand the problem. And then number 4, use symbols till the end. And a very important step of understanding the problem is create clean diagram. Create clean diagrams because that helps you understand the problem. And then write down all the variables. Now next step in our identify which principles can be applied to this problem. So we have to find out the force P, the minimum force P, such that the block does not move downwards. So the first principle is independence of forces. Second is forces can be broken in components and third is the concept of static and dynamic friction. All right, so I see right away that these 3 principles will have to be applied. So let's start with number 2 and see that which force we need to break into components. So see that force Fg will have to be broken into components, because F going downward, P, and force of friction, they are all in the same dimension, in maybe in opposite direction, but force of gravity is little different. It is going downwards. So let's see if we can break force of gravity into components. So here I have drawn it before. So we are breaking force Fg into two components, and because this angle is phi, this angle is phi, so this is Fg cos phi, the force, the component in the downward direction, perpendicular to the plane. This is also called normal force. Normal force, and the downward force is Fg sine phi. So because I'm teaching you how to solve problems, I will not go into more details of this. I recommend you that you invest in learning this. So now go to the number 1 and identify all forces. So let's see if we have accounted for all the forces. All right. So we have force minus F. Let me bring this move this little above, and bring that diagram below. We have them side by side, so it's easy to see. And what we had done, we had broken this Fg into two components. Let me draw the component of interest, which is in this direction, and this is Fg sine phi, and this one is Fg cos phi, and at this point we should erase this so that there is no confusion. All right. Okay. So we have minus F in the downward direction. We have Fg sine phi in the downward direction. Then we have P in the upward direction, and we have friction, the force of friction, in the upward direction. So again, writing it, force of friction is mu Fg cos phi, because the principle of force of friction is that force of friction is mu multiplied with n, which is the normal force, and the normal force in this case is Fg cos phi. All right, so I move P outside and we get this equation, which is P is force Fg sin phi minus mu multiplied with Fg cos phi, and now this is not 0. All right, at this point let's perform dimensional analysis, and you see that this is a force, this is a force, this is a force, this is a force multiplied with two constants. So again, both sides are force. So you saw that up to this point we are using only symbols. You may get impatient that if you were using values like this, it would have been much easier for you to write. But what happens if you're in a hurry to put values, you are not able to test each component of your equation. So for example, you missed this mu, you wouldn't know that. So now we are ready to put values. So we know that let me use all yellow here. F is 3 newtons. Fg we have written above. Fg is mass times gravity. So this leads to 10 mass 10 kgs, 10 meters per second square, and this leads to gives me 100 Newton. So this is 100 multiplied with sine phi, and phi is 45 degree. So sine 45 degrees minus mu is 0.6, force of gravity is again 100, and cos phi is 45 degrees. So we simplified further. 3 plus 100 multiplied with 1 divided by root 2 minus 60 multiplied with cos 45 degrees, which is, and 0.6 multiplied with 100 is, and is 60, and this becomes equal to 3 plus 100, not 100, 100 minus 60 multiplied with 1 divided by root 2, and this becomes 3 plus, and I have done this calculation, 40 multiplied with 1 divided by root 2, and this comes to 31.28 Newton. So let me go over the whole process again. The first step was that we created a diagram to help us understand the problem. We wrote all the variables here in symbols. Then we wrote down the principles of physics we will apply here. Independence of forces. Forces can be broken in components, and the concept of static friction, because this is what gave us this formula that force is force of friction, coefficient of friction multiplied with normal force. Next we broke Fg into components perpendicular to Fg cos phi and parallel to the plane, and then we wrote this equation. So this is your independence of forces. This is your independence of forces because they're all in one dimension. We can simply do arithmetical operation on them. Then we went through the process, we got this final expression, and we put the values. So do not be in a hurry to plug in values until the end. Now let me make one change in this problem. The change is this, and I will underline this. What should be the minimum force value of force P such that the block does not move downward? And I make this, I change this to block does not move upward. So does not move upward. So this is change number 1, and the change number 2 is now it will be maximum. So what is the maximum value of P that the block does not move upward? And let me show you what this will do to our problem. So I have space there, so let me copy this. Okay, let me copy it down below. All right, so in this case the block was about to move downwards, so force of friction acted in the upward direction of the incline. Now in this case the force is, the block is about to move upwards. So let me write it here. The block is about to move upward. So the static friction works in the direction against the tendency of the motion. So static friction works in the direction against the tendency of the motion. Now the block is about to move in this direction. So the force of friction will move in the opposite direction. So what will happen, that let me delete this, force of friction. Will go in this direction, and let's see what this will do to our calculation. So I copy this whole block, here, and what happens now? So all other forces, their direction remain the same, but the force of friction, instead of working in the upward direction, now is going in the downward direction. So let me change the notations wherever friction was involved to something else. So this will become plus, this will become plus. Now when I move P to the left side, this becomes minus. No, this becomes plus. So all right, so now let's change the direction of force of friction. So it's no longer in the direction of P, so this becomes minus, this becomes minus, and when I move P, change to the other side of the equation, this becomes plus, this becomes plus, this becomes plus, this becomes plus, and there sum now their sum now is 100 plus 60, so this becomes 160. And let me do the calculation. So this becomes 116.13 Newton. And in this case, our earlier response was 31.28 Newton. So let's look at the so here we got, let me draw this, bring this response to here. So our response we got was 31.28 Newton. So this is the closest to that. And when we changed one parameter of the question, that instead of looking for a minimum force so that the block does not move downward, to maximum force so that the block does not move upward, the second question, the answer was 116.13 Newton. So let's go back to what we started with. This is the principle. Make sure that you understand the problem, and a very important part of that is you create clean diagrams, identify which principles can be applied to the problem beforehand, perform dimensional analysis at each step, and use symbols till the end. I cannot stress the importance of, see these, that I'm using all symbols till the last step before I plug in the values. All right, so this is the website of Vedant Science Academy. Feel free to contact us if you have a question. Our sessions will start from April 1st. Information about the test, admission test, is on the website. Good luck.